Yeah, I believe I should be live and we're starting this out. So if we go back to our video series with Kubernetes, we were talking about a lot of definitions. So first of all, let's just go back all the way to the beginning where we were talking about what is the difference between a pod and namespace within a cluster, all right? Difference between pods and namespaces. So what is the difference between pods and namespaces within a cluster? Here's a breakdown. So what is a pod? A pod is like a smallest deployable unit in Kubernetes. It represents a single instance of a running process in your cluster. Pods are primarily used to run containers, okay? Usually one or more, and they encapsulate an application's containers along with storage resources, network configuration, and other necessary information. Pods exist within a single node, the physical or virtual machine they're scheduled on, though they may get rescheduled to other nodes if needed. Example used when you deploy an Nginx server or a cloud multi-container application. You're creating pods where each pod may contain one or more related containers. Now, pods contain one or more related containers, right? In summary, pods are about application instances. They contain and manage applet containers that work together to provide a service. Basically, a pod is the smallest deployable unit in Kubernetes, and it represents a single instance of a running process in your cluster. And pods are primarily used to run containers, usually one or more, and they encapsulate an application's containers along with storage resources, network configuration, and other necessary information. Pods exist within a single node, the physical or virtual machine they're scheduled on, and they um, though they get rescheduled to other nodes if needed. And basically, namespaces is a Kubernetes feature that provides a way to divide cluster resources and organize them into different virtual environments. So if you go back, I'm hoping that this is live. Everybody sees me. Hey, we are live. Let send your questions here. Yeah, I normally do this on the weekend, but I just thought let me just complete this series so that we could think about something else maybe in the future. So, a namespace in Kubernetes is a feature that provides a way to divide cluster resources and organize them into different virtual environments. All right. Namespaces help organize and separate resources within a cluster, within a single cluster, especially useful for managing resources in multi-team environments, or creating isolated environments. Now we could have, like, suppose development, test, and production, different namespaces within a single cluster. Basically, these things are they contain. You basically could call them as different virtual environments. Namespaces span across the entire cluster, and you can create multiple pods and other resources like services, deployments within a single namespace. Okay. Example use if you're running multiple projects or environments. All right. Like development, staging, and production, each project environment can have its own namespace. This keeps the resources for each environment logically separated and isolated. Again, in summary, namespaces are about organization and resource separation. They provide isolation between resources within the same Kubernetes cluster. How they work together, basically, you can think of a namespaces as containers for managing and isolating Kubernetes resources like pods. While pods represent the actual workloads running in the cluster, namespace organize these workloads and their associated resources, creating isolated spaces where resources are not directly visible or accessible across namespace boundaries. What's the difference between control plane and nodes, right? In Kubernetes, the cluster consists of two main components, the control plane and nodes. Together, these components manage and run your containerized application across the container cluster. These are some common questions that I'm going over. Okay, so now what is it? Control plane. The control plane is like the brain of the Kubernetes cluster. It manages the state of the cluster, ensuring that applications are running as intended. Now, key components of the control plane basically include API server, which acts as the front end for the Kubernetes cluster. It handles RESTful requests to interact with cluster resources by creating or modifying pods, deployments, and services. Now, these are some of the key components of the control plane, which is like API server, scheduler, controller manager, node controller, replication controller, and then we have endpoint controller. And etcd is basically a distributed key value store that holds all cluster data, including configuration, status, and metadata. Purpose of the controller plane is like the control plane manages the cluster's overall state, schedules tasks, and maintains communication with nodes to ensure applications are running as intended. Basically, what I'm saying is that the control plane is like the brain of the Kubernetes cluster, and it controls the state of the cluster, ensuring that the applications are running as intended. API server acts as the front end for the Kubernetes cluster. It handles RESTful requests to interact with cluster resources like creating or modifying pods, deployments, and services. Now you can think of the services like group of pods together. Basically, a pod contains one or more running containers, right? And they group together to form a particular resource. And basically, they are like like pods are like runnable resources, right? A single resource. And um, scheduler basically determines which node should run newly created pods. So basically, nodes run the pods, right? Based on resource availability and policy. Now, this is the thing what we're going to be thinking about. This is like the API server front end for the Kubernetes cluster. API server is like the front end, and then we have a controller manager, ensures that the actual state of the cluster matches the desired state. All right, the control manager. So that's why we're saying that the actual state of the cluster matches the desired state. It has several components such as like the node controller, monitors the response to changes in node availability. Remember, nodes are like um, virtual machines or computers that run these particular pods, right? And those pods run multiple containers. The replication controller ensures that a specified number of pod replicas are running. Again, we need pod replicas because that's how scaling works, distributed scaling. Endpoint controller manages endpoint objects to make services reachable. And then etcd again, finally, like I mentioned, is a distributed key value store that holds all cluster data, including configuration, status, and metadata. Um, Basically, the control plane manages the cluster's overall state, schedules tasks, and maintains communication with nodes to ensure applications are running as intended. Okay, what are nodes? Are the machines, like virtual or physical, within the cluster that actually run the containerized applications, okay? Each node has its own internal services to communicate with the control plane and execute workloads. It had like a direct communication with the control plane for basically the control plane, remember, is like the brain of the cluster. So key components of a node basically is kubelet, an agent that runs on each node and communicates with the control plane. Basically, this is what it's used to run communicate with the control plane to manage the pods. Remember that a node has pods, runnable pods. The kubelet makes sure each containers are running in. Then the containers are inside the pods, right? So we're making sure that the containers are running in a pod. Youth kubelet. Then we have a container runtime runs the containers like Docker containered Kubernetes relies on this runtime to start, stop, and manage the containers, which is the container runtime. And then we have kubeproxy, which is manages networking on each node, enabling communication between pods and other services within and outside the cluster. Purpose of nodes. Nodes are where the actual workloads like the containers run. Following instructions from the control plane, each node can have multiple pods, and Kubernetes dynamically assigns workloads to nodes based on availability and resources. Multiple pods meaning multiple scaling and more safe. So the application or services can be distributed and available as accessible need as per requirements. Long time no see. No, do you do Node.js videos in the future? Yeah, we will. Thanks for reaching out, Kwang. We will definitely make some future Node.js. Node.js is one of the best, and I really enjoy coding in Node.js. And this video, we're just talking about Kubernetes and stuff. So, if you like it, just follow away. I'm going to be doing a practical shortly. So this is like the final, almost like the final video for that series that we were doing. Hopefully in the future, we will do a touch upon Kubernetes, Dockers and stuff in different things. But this was like a sequence series. So what do we do is how they work together. Now, again, the control plane manages what needs to happen, like creating new pods or scaling replicas. And what the nodes are responsible for doing the actual work, like running containers as directed by the control plane. Now, example workflow, you can think of it like this: a user requests to deploy a new application. The control plane, basically the brain, schedules the application on available nodes. Now the nodes are like the running, virtual or physical machines within the cluster that actually run the containerized applications, right? Nodes run the application in pods. Again, inside the node, there's different pods, and within the pods there are the containers. Nodes run the application in pods and report back to the control plane on their status. Basically, the control nodes is like the thing in charge. So the control plane constantly monitors nodes to ensure the desired state of the cluster is maintained. Now, there's another question that says, what does fleet mean? All right. In the context of Kubernetes or similar container orchestration systems, right? Yeah. Fleet is typically refers to a group or collection of clusters. It's an organizational concept used when managing multiple Kubernetes clusters, especially in large-scale or multi-regional setups. Key points about fleet management: you might be asking, what's the benefit? When you have like so many clusters, right, created, so you can manage them all using a single name like fleet management. All right. So what is a multi-cluster management? When a fleet allows organizations to manage multiple clusters as a single entity. That's pretty cool. This can be essential for enterprises that have clusters distributed across different regions or environments. Well, like suppose we have a development cluster, a staging cluster, and production cluster. We could put it as a single fleet and call it as organization 101 fleet. All right, and it contains all three clusters. Centralized control. Using a fleet, administrators can apply policies, monitor, and deploy applications consistently across all clusters. Basically, you have a centralized control. And tools, some fleet management tools in Kubernetes include Fleet by Rancher, Anthos by Google Cloud, allow centralized management of clusters across on-premises, Google Cloud, and other cloud providers. Basically, this is a fleet tool. And Azure Arc for Kubernetes, Microsoft's solution for managing Kubernetes clusters across on-premises, edge, and multi-cloud environments. And then we have Fleet by Rancher. Rancher's Fleet is an open source Kubernetes fleet manager. Basically, that's the open source one that allows you to manage thousands of clusters with consistent deployments and configurations. That is so powerful, actually. Anthos is pretty powerful as well. Why use fleet management? Fleet management is crucial when scaling. Organizations operate a high number of clusters and need unified management, right? That's perfect. Consistency, there's a need to enforce uniform policies and deploy updates across clusters. That is so crucial in enterprise level productions, that we need to inform uniform policies on on each cluster, and you don't want to practically do that separately one by one on all clusters. You want to have a you don't want to have a basically a centralized control to manage all your thousands of clusters you created, right? And then we have cross-region requirements when applications or services must be available in multiple regions. A fleet helps coordinate deployments across regional clusters. Example use cases, suppose a company runs applications in clusters across the US, then we have Europe, and then we have Asia. Okay, three different places. To reduce latency for users in those regions. Suppose it's a game like PUBG. Now it has clusters in US, Europe, and Asia. A fleet manager can deploy a new version of the app across all clusters. All right, and ensuring consistency and making it easier to monitor and troubleshoot globally. Basically, making these clusters accessible within different regions allows you to have reduced latency, and then when a person is connecting to that particular game, it will be available to it will connect to its nearest region, right? Thus reducing the latency. And when you want to upgrade a new version, you could upgrade it one time to all of these, right? Making it very convenient to monitor and troubleshoot your application globally. Awesome. I love that use case, and this is one practical need for why people normally use fleets in organizations. So far, so good. Okay, so what's the difference between pods and nodes in Kubernetes? Again, I think we mentioned this. So, uh, pods is basically the smallest deployable unit in Kubernetes. It represents one or more containers that are running together in a shared environment. Actually, we didn't go over the pod. Pods are designed to host your applications. Each pod can contain one or more containers that share the same network namespace and can communicate with each other using localhost. Now, pods are created, destroyed, and recreated dynamically based on the desired state you define in your Kubernetes deployment configurations. If you have a web application that consists of a front end and a backend service, you might have two separate pods, one for the front end container and another for the backend container. All right. And these are some of the characteristics. So that's what I would recommend checking it out. Let me just drink a glass of water. Going over the questions if there's any. Any questions so far? Yeah, I just put a poll as well, for those who are interested. You could answer that, but yeah, if you have questions. Oh, okay. So these I haven't tried before, but super chat and stuff. Wow, that's crazy. And you could check these out as well. Just unlock them. And then we have these are the free ones, but yeah, if you want a super sticker, super chat make your messages stand out. So you could stand out by sending a message like that, increase the rate. Wow, that is actually super cool. Okay, so send and buy, and it's like pinned for 5 hours, pinned for 1 hour, pinned for 10 minutes. Oh wow, these are pretty convenient. Anyways, let's go back. Yeah, so this is my dashboard, what I'm going to be doing, which is with Google Cloud. But before that, let's just complete on the theoretical aspect of it. Um, so remember, a pod is the smallest deployable unit in Kubernetes. It represents one or more containers that are running together in a shared environment. And pods are designed to host your applications. Each pod can contain one or more containers that share the same network namespace and can communicate with each other using localhost. Now, if you have a web application that contains of a front end and back end service, you might have different pods. Now, if you look at this, we have sharing resources. Containers within a pod share the same storage and network resources. Communication pods communicate with each other using localhost, making it easier for tightly coupled applications. If we look at nodes, a node is like a physical or virtual machine that is part of a Kubernetes cluster. Each node can run multiple pods, right? Nodes provides the computing resources like the CPU, memory, and storage necessary to run pods. They are the machines where your applications actually execute. And then we mentioned components. Each node runs several essential components, including the kubelet, an agent that ensures the containers are running in a pod. And then we have container runtime software responsible for running the container. Docker. And then we have kube proxy manages network routing for the services. Now, there's like resource management. Nodes are responsible for allocating resources, CPU memory to the pods running on them. And then we have health monitoring. The control plane monitors the health of nodes to manage workloads effectively. And then you know that a pod is the smallest deployable unit in Kubernetes. It represents one or more containers that are running together. In a shared environment, pods are designed to host your applications. Each pod can contain one or more containers that share the same network namespace and can communicate with each other using localhost, and they're created, destroyed, and recreated dynamically based on the desired state, defined in your Kubernetes deployment configurations. If you have a web application that consists of a front end and back end service, you might have two separate pods, one for the front end container and another for the back end container. All right. And you look at the summary of differences. Pods are like the smallest deployable unit, one or more containers, and a machine. Basically, a node is a machine, physical, virtual in the cluster. Then we have purpose, basically, pods host applications containers, whereas node provides resources, CPU, memory, storage. Lifecycle, if you look at it, we have created and destroyed dynamically, and nodes are like generally more static but can be added or removed. Then we look at communication containers within a pod share networking. And then we have nodes communicate through the nodes networking. Contains one or more containers. And then we have nodes runs kubelet, container runtime, kube proxy. So over here we have smallest deployable unit, one or more containers, which is a pod, and a machine is a physical virtual. The cluster host application. So I guess you understood the key difference here of the smallest deployable unit, one or more containers, and basically node, which is a machine, physical, virtual in the cluster, host application containers, and yeah, I hope you understood this difference. Like pods, like the smallest deployable unit, one or more containers, and basically a node is a machine, physical, virtual in the cluster. Host applications containers, pods, and then nodes basically provide resources, CPU, memory, and storage. Pods basically created and stored dynamically, right? And nodes are generally more static, but can be added or removed, right? Pods, like what I said, is created and stored dynamically. Now we have communication. Containers within a pod share networking, and then pods communicate through the nodes networking. So we understand the life cycle that created and stored dynamically, and nodes are generally more static but can be added or removed. Yeah, so if you have questions about this so far, you could let me know. This is basically the key difference between a pod and a node. Whereas a pod is like the smallest deployable unit, and a machine is basically a physical or virtual thing in the cluster. Purpose of a pod basically hosts containers, and nodes is essentially something that provides CPU, memory, storage. Um, you could think that the life cycle is just created and stored dynamically. And they're like dynamic things. They're basically hosting containers, right? One or more containers in a pod, which is the smallest deployable unit. Nodes are generally more static but can be added or removed. Again, containers within a pod share networking and contains one or more containers, right? This is what it's called, a pod. Whereas a node has pods communicate through the nodes networking. And then we have runs kubelet with the node container runtime kube proxy. Okay, you can think of this as a visual analogy where think of a pod like an apartment where one or more people, containers, live together and share resources like utilities, basically network and storage, right? Node is basically, think of a node as a building that contains several apartments, all right? Pods. The building provides the infrastructure and utilities that allow the apartments to function. Exactly. Without a node, you cannot have pods. By understanding these distinctions, you can see how pods and nodes interact within the Kubernetes architecture, where basically pods serve as the operational units running applications, while nodes provide the underlying infrastructure necessary for those applications to run. I think that's pretty much it with that. We're basically following this part out. So tracking and visualizing. One second. Yeah. So I'm just gonna close that out. Okay. So now we're in the last part of this video. We're basically going to track and visualize trends in your GKE clusters, namespace, and pods. So basically what I'm going to do is I went through it and wanted to track some changes, right? We're basically tracking and visualizing trends in your GKE Google Kubernetes Engine clusters, namespaces, and pods. All right, it's straightforward with Google Cloud Monitoring. This built-in tool works seamlessly with Google Kubernetes Engine and provides insightful metrics for namespaces, pods, and more. Now, here's how we can set it up without burning through your free trial that Google Kubernetes provides, $300 free credit. Yeah, remember namespaces is like a virtual environment inside the cluster, seeing like the dev staging test, basically like development, staging, and testing. Inside of that, we have different nodes, virtual machines or physical machines that contain resources, compute resources. Inside of those virtual machines, pods run. So pods contain one or more containers, and these pods are basically the smallest unit deployable, smallest unit of something that's deployable within Kubernetes. And then inside of these pods, we have the actual containers which are basically the application with all the resources. You'll have more than one, and that's how the entire ecosystem of this works. If there's multiple containers, they work in a fleet. And what we're going to be doing is trying to track and visualize like the number of namespaces we create and the number of pods that we create inside of our cluster. So set up your GKE cluster, enable GKE API. What I'm going to be doing is I'm going to put this on the uh, 1 second. So I'm going to open it up. So I'm going to open this up on the right side and this on the left side, which is my Google Cloud Console. The Google Cloud Console will show me the visualization for the charts and every process that I would go through. And I would have my instruction set, which I opened up with ChatGPT to allow me to have all the steps needed uh, to make it work. So now I'm going to dock it on the left. For some reason, it's not working. Let me see. I think I gotta turn this thing off. Uncheck. Because I had my laptop connected as well. 1 second. Where is it? 1 second. This one? I could basically separate this and put it right here. Okay, now we have the instruction set on the right. Perfect. So let's go and you know, visualize this. Now we're gonna set up our GKE cluster. I did this in the beginning part. This is my first project. It's basically free. It's for the billing period of November 1 to November 5, US dollars 0, and I have a free tier. You all could unlock it. Go to the pin products navigation menu, log into the GCP console, search for Kubernetes engine. Make sure when you go here, go to the search, open search, and you type in Kubernetes engine API. Click on that, select this one, and make sure it's enabled. API is enabled for me. It builds and manages container-based applications powered by the open source Kubernetes technology. Once the Kubernetes engine API is working, we have to create a Kubernetes cluster. In the console, go to Kubernetes engine, clusters, and create clay. So we go to the navigation bar, go to the Kubernetes engine, basically, which is right here, and then the clusters. Over here, you would have a create button, but since you created some, you'll see them on the bottom. So you hear that there's a pilot mode. And then you can see you want to create a minimal cluster US Central 1C. Nodes are 1, total virtual CPUs are 2, total memory is 1 GB. Pods, unscheduled, verified webhook endpoints. Now you could see that this is here. I could delete my and connect it and edit it. I would recommend choosing a standard cluster, not a la carte, since it's pricier. Then cluster basics, name your cluster and select a nearby zone. Put it close to your region so it could cost less. Node pools, to save on cost, start with minimal nodes, try just one, and use a small machine type like E2 micro. And then we have click create to spin up the cluster. Connect to your cluster, open the cluster. When the cluster is ready, click connect. Follow the instructions to set up kubectl access. You can do this in Cloud Shell or on your local machine if you have the Google Cloud SDK and kubectl installed. Now this is the step where we stop. I click on this connect button. It opens up this connect to the cluster. You can connect to your cluster via command line or using a dashboard. All right. Now, command line access, configure kubectl command line access by running the following command. All right, this is the run in Cloud Shell, which Google provides, and Cloud Console dashboard. You can view the workloads running in your cluster in the in the Cloud Console. Open workloads dashboard. We could do that, but in the beginning, what I would do is I would first of all make sure I have the cloud installed. So if I go here, this is nothing. So I'm gonna cross this out, and I'm gonna open up my command prompt. And what we're going to be doing is we're just going to type in this. If gcloud version, if I do this, it will tell me if I have gcloud installed or not. The last time I believe so, I did set up the process, but it will tell me over here if I have it on my machine or not. And the other thing we need is kubectl. So over here you can see we have Google Cloud SDK running. That's perfect. The other thing that we have to check is kubectl. This is Kubernetes. So kubectl version. And it says we have client version and customized version and able to connect to the server. That's amazing. We have both things installed. Perfect. Now, I wouldn't prefer I would prefer having some kind of file. So if I go to File Explorer, right? And if you're go to the documents or the downloads and just create a folder here for now. I'll say K8 practice. Not the best place to put a folder, but you know, it will do. It would suffice. So go here, CMD, and that's it. I would run the commands within this instead of just like normally on my C drive. So I'm just gonna exit this out. All right. And the first thing what we need to do is we want to connect with our cluster. We have gcloud container, clusters, get credentials, minimal cluster, zone, US Central 1C, project secret. So this command will allow me to connect to my cluster. If I run this command, so let's see what happens. So it says over here, do not error. Gcloud container clusters get credentials. You do not currently have an active account selected. Please run gcloud auth login to obtain new credentials. If you have already logged in with a different account, run gcloud config set account. Select an already authenticated account to use. All right, so we could basically log in, say gcloud. I did this practical earlier where we in the quick labs gcloud config set account and then we put our account. But we'll just use all to log in to authenticate. Remember, I could use this Cloud Shell tool that it has, but I'll just try to do it within my terminal, see if it actually works out. We always so just click on your account and continue. So once it has, it will just this will allow Google Cloud SDK to see, edit, configure, and delete your Google Cloud data and see the email address of your Google account, view and sign into your Google Cloud SQL instances. Then we have view and manage your Google Compute Engine resources. And then we have view and manage your applications deployed on Google App Engine. So I'm going to click on allow. You're now authenticated with Google Cloud CLI. And you can see over here that you are now logged in as my email address. Your current project is none. You can change the setting by running gcloud config set project, and we have project ID. Um, so if I go here and I run the command, which is this one, we still cannot action required plugin, which is needed for continued use of kubectl, was not found or not executable. Install GK Cloud Auth plugin for use with kubectl by following this thing. Kube config entry generated from minimal cluster. So GK Cloud Auth plugin, we need this thing, Cloud Auth plugin, authentication plugin, which is needed for continued use of kubectl. It was not found or is not executable. Install GK Cloud Auth plugin for use with the kubectl by following this. So you just go here to this link. I'll just put in the new browser. And GKE, install the required plugins, right? So before you begin, check whether the plugin is already installed. Just copy this and paste it. GKE gcloud auth plugin. If it's not saying it's recognized is not recognized as an internal external command, operable program, or batch file, means that it's not installed. So what you could do is you can install the authentication plugin using the gcloud CLI or an external package manager such as apt or yum. But we're going to be installing the GK Cloud Auth plugin binary. Just going to copy this command and just going to paste it in right here. So 1 second, if I go here and I just copy this gcloud component install GK Cloud Auth. Yeah. So this is going to download the GKE gcloud auth plugin binary. Go back here. For some reason, it does not paste it. I might have to copy it manually like this and then paste it right here. gcloud components install gcloud auth plugin. It's going to take some time, but it's going to install it for us. If there's any questions, any recommendations, or anything like that, feel free to let me know. Yeah, so this is good for deployments, and I would highly encourage to check it out. Yeah, so we'll make sure that this is installed. It's gonna take some time. I'll be just right back. All right, so we got this information where it says the current Google Cloud CLI version is 499.0.0 and installing components for version 499.0.0. Okay, Google Cloud CLI version. Now, if you look at this, these components will be installed. It's basically a GKE Cloud auth plugin, platform specific, and this is exactly what we need for connecting our Kubernetes thing. So for the latest full release notes. You could check that. Once started, canceling this operation may leave your SDK installation in an inconsistent state. So, do you want to continue? I'll say yes. And performing in-place update. So it's downloading GKE gcloud auth plugin, GKE gcloud auth plugin platform specific, GKE gcloud auth plugin, and GKE gcloud auth plugin platform specific. They're performing post-processing steps. It's gonna take some time, and it's gonna install it for us. So yeah, I'm just grabbing some juice. You finished it? No? No. Okay, it's still performing the post-processing steps. Um, just waiting until it's completed. Um, and yeah, if there's any questions so far, feel free to let me know. The highest peak we got was 3. Let's hope we could get more than that. And yeah, let's just make sure that that is done. We can move forward afterwards. So installing the GK gcloud auth plugin, and after that we could move on to the next steps. Yeah, it's taking a bit of time. It shouldn't be taking that long. I just hope it's done quickly. If it doesn't go well, I always have that backup option of using Cloud Shell, what Google provides. But it just needs like this Google Kubernetes, G Cloud authentication plugin. If we get this authentication plugin, it would be working. And it's literally just 4.1 MB. It shouldn't be taking that long. Finally, update done. Press any key to continue. So we're gonna press the enter key. Oops. We're gonna press the enter key. We're done with that, and it should be installed now. Again, you could basically check that out. You know, this thing. So you just go and do this command, and it tells you that you have a authentication plugin. You know, it gives you a version ID or something, which is cool. Now, again, let's go back. I believe we could now connect it. So we have this G Cloud authentication plugin down. Let's go back, and I think we were trying to connect our cluster, command line access, container clusters, get credentials, minimal cluster, fetching endpoint and auth data, kube config entry generated from minimal cluster. Awesome. We've just connected to minimal cluster. That is so cool. Okay. So now that we have that done, set up cloud monitoring for namespaces and pods. Okay. Enable Google Cloud Monitoring. Now we're gonna go and press OK. Okay. We're gonna enable Google Cloud Monitoring. We're gonna head to monitoring in the console. If you go to the option here, we have the option of just Google Cloud, and there should be like a monitoring option. But anyways, after that, it's saying if it's your first time, click Add your first cloud environment and select Google Kubernetes Engine to enable monitoring. So head to monitoring in the console. If you could find that, let's see, navigation menu, billing, Kubernetes Engine, cloud storage, just see all products. Find and deploy over 4,500 products in marketplace. So I'm just gonna look for monitoring. It should be with M. Management. I'm trying to find monitoring. So networking, distributed cloud, serverless, databases, observability, and monitoring is finally here. Understand the behavior, health, and performance of your applications. So in the logging, reporting, monitoring, error reporting, and trace, have latency insights. We have monitoring infrastructure and application quality checks. So we're gonna click on this monitoring. Add your first cloud environment. So go here. We have alerts, 0 services with SLO, out of budget, failed uptime checks, VMs with ops agent, cloud observability, logs, dashboards and integrations. Yeah. So we kind of have count of virtual machines. We have one. It's green. This is CPU utilization by zone. 46% is saying that it's being used, are good for identifying anomalous metrics. And you can see 46.10% value. So what we want to do is we want to click on add your first cloud. So it's your first time, click add your first cloud environment and select Google Kubernetes Engine to enable monitoring. So I'm trying to find that option, add your first. Where could it be? Overview, dashboards, metrics explorer, logs explorer, log analytics, trace explorer, uptime, synthetic monitoring, SLOs, integration, log based metrics, log router, log storage, metrics management, groups, settings, permissions. There should be an option, customize. Let me see, click on it. Exit edit mode. Cloud observability. Cloud observability. What does an SLO mean? So let me just go back. um, into the monitoring place right here. Add to monitoring in the console. If it's your first time, click add your first cloud environment and select add your first cloud environment. Check synthetic learning. We're gonna go on the dashboards of monitoring. Now import Grafana dashboards. You could import them. Create dashboard, dashboard templates, and we have all dashboards here. We have custom ones. We have not created. GCP provides these dashboards by default: autoscaler monitoring with disk firewall, GKE clusters, and some log dashboards and VMs. And total is basically this. If I click on create dashboard. Okay, let's just go back 1 second. Oh, and then it just creates our new one. Then you could delete dashboard right here. Okay. So let's go overview. So I'm trying to find the option to. Okay, it says, here are some sample dashboards for observing workloads on GCP. VM instances dashboard, GK compute resources, and logs dashboard. Um, so I'm gonna go back here, and possibly what I'm gonna be doing is I'm gonna ask. Okay. From step 2, I can't find the options within the Google Cloud Console. Okay. It sounds like the Google Cloud Console interface may have shifted, so let's work through the steps with a focus on what might be slightly different in the UI. Here's an update. So set up your GKE cluster, enable the Kubernetes engine, create a cluster. We've done all of that. Connect to your cluster. We've done that. We either connected with CloudShare or your local machine with Google Cloud SDK, Software Development Kit, and kubectl installed. Cloud monitoring for namespaces and pods. Enable Google Cloud monitoring. Navigate to monitoring in the Google Cloud Console. We are there. If it's your first time, you might see a prompt to add your first cloud environment. Select Google Kubernetes Engine to enable monitoring for your cluster. So I'm trying to find the cloud. So what I'm gonna do is I'm gonna basically try to monitor it. Um, so you could see some CPU utilization happening in November 5. Right now it's dipped, but it's constantly on. Um, Explore featured products. Discover and monitor all Google Cloud resources and services with no additional configuration. Integrated right into the Google Cloud Console. Start your monitoring journey by simply running workloads on any of the supported Google Cloud products. Now, we're in the overview side, explore featured products. So we have Google Kubernetes Engine. I might click this one. And now it's right steps to set up GKE. Now it's even easier to set up GKE. Learn the best practices and recommendations on how to run production grade GKE clusters. So this kind of look like a course. Um, Click on this. We have the option to connect, observability, cost optimization. Again, now we basically went back to the Kubernetes engine place. What we have to find is basically I have to find my ad for these are the fleets that I was mentioning. We now have no resources so far. So let's go back to the Google Cloud Console and we're gonna go to the monitoring side. Products. And billing, IAM, resource access control, Google Cloud setup, compute, storage, analytics, networking, distributed, serverless databases, observability. And then that we have this, show more, docs and quick starts, infrastructure and application quality checks, ensure your systems are running reliably with tools like dashboards, alerts, and uptime checks. Click on this. Um, and what you want to do here is you want to cross this tutorial out. There's a lot of things like Cloud really offers a full suite of features for monitoring and troubleshooting your workloads, from logs, dashboards, alerts, and traces to SLO and uptime checks. You can optimize this page and quickly access the views that matter most to you. Cross this out. Um, Customize. Go over here. Customize dashboard. So we have Google Compute Engine, Observe VMs. You could just cross this. Collapse, expand. So collapse group, expand. You could expand this one. Observe clusters. We have a single cluster and it's giving some data about it. Then we have other like Kubernetes additional visualizations. And you can see some stuff like this stuff with the value of 45.85 kind of virtual load balancer P95 latency. No data is available for the selected time frame. Let's go back up and you have uptime checks and stuff like that. I believe so that we have enable auto refresh, shift time forwards. Um, VM instances dashboard. So I think we're gonna have to like customize something. And ops agent, the operations agent is a primary agent for collecting telemetry from your cloud engine instances, combining logging and metrics into a single agent. The ops agent uses FluentBit for logs, which supports high throughput logging and the open telemetry collectors for metrics. You can also configure the ops agent to support metrics and logs from third-party applications. You could click on setup agents, and we have a GKE minimal cluster default pool. Not applicable. So let's just go back. These are the dashboards. Let's go back again to the overview. Metrics Explorer. We're going to add a query, Logs Explorer. So these are different logs. Okay. After that, we have Log Analytics. And we also have get started with Log Analytics. So transform, group, aggregate, and chart log data to generate deeper insights from your logs and reduce troubleshooting time. There's no additional cost for upgraded log buckets or for running queries from the log analytics page or upgrade other bucket. So let's just go Trace Explorer. Find performance bottlenecks in production. Alerting, error reporting, uptime checks, synthetic monitoring, SLOs. You can click on this. Um, Secure monitoring helps you monitor the health of Google Cloud microservices by providing the tools to set up alerting policies on the performance of a service level objective, a measurable goal for service performance over a period of time. So we have services. None of them are like listed at the moment. Release notes and toggle monitoring navigation menu. So error reporting and stuff like that. Metrics, Explorer, dashboards, and basically that's pretty much with all of our information. PromQL, um, duplicate query, line chart, stack bar chart. We have a stacked area chart. We have a heat map, table, and top list. Analysis and all that. So let's just go back to the dashboards or the overview. And select Google Kubernetes engine to enable monitoring for your cluster. Um, so I think it's added. Perhaps if it's added, we could go to the next step. Verify Kubernetes monitoring. This monitoring setup should install a monitoring agent on your nodes automatically. So a monitoring agent, if I saw somewhere like there was like a monitoring agent. If I go to the steps over here, integrate with Google Cloud Services, collect additional systems and set up agents. Okay, not applicable. And those GK and Dataproc VMs are Google managed and include built-in agents. So you could click on this. Connect. Window, open in browser window on custom port, open in browser window using provided private SSH key, view gcloud command, use another SSH. Open in browser window, okay? So let's open this up. Please consider added the. So yeah, we are welcome to Kubernetes V8.10. So you got to see that we are basically in our cluster. SSH in browser. You could do the same commands like we were doing, like gcloud version. Okay, that doesn't work. So So we could just, download a path, absolute path, like C drive. Let's see over here. Suppose if I say in this path, download whatever file they give, you could new connection, scroll bar, keyboard view, font, courier, theme. You could just exit it out, and it says over here that's not applicable. Okay. So we have this GK with the CPU utilization. We have network traffic, disk throughput, packet, network packets, disk IOPs, CPU summary, and stuff like that. Okay. Go to the observability of this GKE minimal. We have all this stuff that we could see. Okay. Okay, so let's go back to the options here. This monitoring setup should install a monitoring agent on your nodes automatically. So confirm following, run the following in your connected cloud shell or terminal. Okay, we're gonna have to run this. The output should show a stack driver agent running if monitoring set was set up correctly. This agent gathers metrics on namespaces, pods, and more. So let's just run that. grep is not recognized an internal external command. So let's say, oh yeah, create virtual image. So you'll basically activate Cloud Shell, and this should authenticate with your existing image. Now go here and paste this command. Sorry, not this one. Delete all of this. Okay, if I paste this command, which is this one, copy, and paste this one. Let's see. Okay, well, there was a connection refusal. So we're gonna have to connect with the Cloud Shell as well. So I would prefer exiting out and we'll just ask the question, when I try to do the command in step 2, I get the above error. Can't find the way to install the agent within my cluster, minimal cluster. Happens because grep is a Linux-based utility and isn't available by default. There is an alternative approach to check the stack driver cloud monitoring agent on Windows and ensure it's installed in your GK Use PowerShell's equivalent for grep. Instead of grep, you can use PowerShell's string select string command to filter the output. Open PowerShell and on the following select string. Okay. Okay, we're gonna have to go to PowerShell instead. Okay, we could use kubectl describe method as well. Daemon kubectl describe daemon set --hyphen namespace kube system. Look through the output for any entries related to stack driver or cloud operations. If it's not there, agent might not be installed. So it gives a lot of stuff. Yeah, it gives a lot of stuff to output. Yeah, that's a lot to search. Install the monitoring agent manually. If the agent is installed, you're going to manually deploy it to your cluster by applying Google's configuration on the monitoring. Apply the monitoring agent daemon set. Run the following command to deploy the stack driver Kubernetes monitoring agent. So what we're going to be doing is we're going to copy this, verify the installation. Cloud monitoring allow you to track namespaces, pods, and other Kubernetes resources. So we're going to apply this. Copy this. If the URL method fails, you can download the YAML file manually and apply it within your. If the URL method fails, you can download the YAML file manually and apply it from your local machine. Download the YAML file. Okay. Once downloaded, navigate to the file directory and run. So, okay. So let's try this one. The updated link. We're getting a 403 not status code 404 not found. So let's just check permissions to verify the stack agent driver. Stack driver agent, you may need to ensure that your GK cluster services account has the required permission. Enable cloud monitoring API. Go to the Google Cloud Console and navigate to API and services. Enabled API and services. So, and navigate to APIs and services, and then we have 1 minute. So, let's put it over on the right, this side. So, what it's saying is basically, yeah. So we're gonna go to the Google Cloud Services, API and services, and API and services, enabled APIs and services, and then we're gonna go to library. Search for cloud monitoring API, enable it. Cloud monitoring API. The stack driver monitoring API allows you to give access to your to over 900 stack driver monitoring injects from Google. Okay, stack trace API. We have stack driver monitoring API. Basically, it's enabled, this one. So yeah. And this is enabled as well. Assign monitoring permissions. Go to IAM and go to IAM. So and admin. IAM and Google Cloud Console. And you can see over here we have this principal compute engine default service account editor. So over here we can see that look at the service account used by your GKE cluster usually has add GCP SA. I think it's this one, principal, in its name. I don't see stack driver. I see G service account editor. Uh, and ensure it has monitoring metric writer and monitoring viewer roles. G service account and it's GCP SA stack driver. Okay. After you ensure permissions and apply the so we see that we have to go back into the APIs and services, enabled API and services, or library. And in the library, when we search in Cloud Monitoring API, maybe it could be something that I have gives me Cloud Trace API enabled and Cloud network stack driver monitoring API enabled, but I don't see any of the updated roles in the IAM. Then let's see this one, if this one's enabled. Oh, it's not this one. So it says it's unlike the cloud monitoring API and stack are all enabled, so you'll make sure that the necessary roles are applied to your GKE cluster service account. Step-by-step guide to assign the monitoring metric writer and monitoring viewer roles. Identify your GKE's cluster service account. Go to clusters in the over here. The Google Kubernetes engine. We have the clusters. Click on GKE to open its details page. So we'll click on this. Okay. In the details tab, look for the service account associated with the cluster. Usually something like. So we have your cluster has one or more unscheduled pods. View details and possible. Use verify webhooks with unavailable web points. So we have some issues over here. Delete, node pool, deploy, connect, and duplicate. So over here we have a lot of these things. And it says look for the service account associated. So we have service account associated with it. I do not see. Security. So we can see that the standard support will be ended on September 29. So that means I'm going to be deleting this myself. Upgrades, unavailable. automation, and control plane networking, cluster networking, default new node pool configuration, security, metadata, description, features. Your project, service account. I cannot find the service account. Marketplace, gateways, features. So security. There's a lot of apps that you can download over clusters. Overview, workloads, applications, security, config maps, storage, object browser, rollout sequence and backup for GKE, security, service mesh, config, identity service. Service mesh. So I guess we could search this. I don't think so it's going to be there. Let's just search this. Control F. Over here. Yeah, just as expected, it didn't even exist, something like that. Teams. Yeah. So we're going to storage nodes. So yeah, storage. If we look over there. So I'm just gonna finalize the thing. Doesn't matter. Some of the commands were working before. So let's go back. Let's go back here. So we were here, and we're just gonna try to close at the end. So yeah. So let's go back in this place. Monitoring dashboard. In the monitoring, go back here and view all products. And you go to the monitoring section, which is all the way to in the observability. Pin this to your menu. You go to the dashboards, click create dashboard and give it a name like namespace and pod tracking. So we're gonna go and create dashboard over here. There's 29 by default, which GCP provides, like autoscaler monitoring disks, firewalls, GCE, interactive playbook, GKE, and stuff like that, VM instances, virtual machine instances, logs, dashboard, infrastructure summary, Google Cloud load balancers. We're going to create a dashboard and we're going to give it a name. So we could give a name like, what's it called? Namespace and pod tracking. Okay. After that, create dashboard. So we have custom, I think it's this one. It's just gonna reflect it. So click on it. Yeah, this is our custom dashboard. Add namespace metrics within your dashboard. Click add chart. So there should be an add chart button. Add widget, I only see. Just open it up. No widget configured. So we have annotations. And here we have view all dashboards. Create dashboard. Custom label none. You could add another one. Oh, okay. I understand. So we're just gonna go back to our namespace one. Add widget. We have add dashboard namespace one. Two favorites. Toggle full screen mode. Dashboard settings. Manage layout. Manage filters and variables. Modes. Legends. JSON. Send a copy dashboard. Delete dashboard. What I'm gonna be doing is I'm gonna add widget. So it says add widgets configured to display any metric data collected by your project, including custom metrics, so you can spot trends or issues before they happen. Add a widget. Then we have metrics, logs, observability, analytics. That's for data. That's for detection. This is for visualization. It's for layout. Okay, these are widgets. So what we need, if we go back here, chart. We need a chart. So that's basically in the visualization. There should be a chart. Pie. Stacked area, line, stack bar, gauge, top, geomap. The only thing that I see as a chart is like a pie chart. Okay. So I'm going to click on this. Okay. After that, we have open the monitoring dashboard. In the monitoring dashboard, click create dashboard and give it a name like namespace and pod tracking. Add chart in the metrics dropdown, search for Kubernetes namespace. Oh yeah, so select a metric. Okay, I guess it's like this one. Yeah, in the metric dropdown. There you go. We're doing well. We are doing well. So in the where are we, man? Let's go back on the top. Yeah, so I guess we're over here. Um, I believe so. Just one second. Yeah, so yeah, we are over here. Yeah, so we were over here where we had to add a chart for pods, click add chart again. Okay, add a chart for namespace. So in the monitoring dashboard, click create dashboard and name it namespace and pod tracking. Add a chart for name in the dashboard, click add chart. Select the metric dropdown and search for Kubernetes namespace metrics like resource usage or count. So select a metric, it's filtered by resource or metric. Select them and search for Kubernetes namespace metrics. Okay. Resource usage. So we could say that's not there. Count. Okay. Anyways, active resource, audited resources, compute resources, consumed API, global Kubernetes container, virtual machine instance. So we have Kubernetes container, popular metrics, container. What is in the CPU limit, CPU usage, memory limit, memory usage. If you look at the container, we have a namespace. Global, memory limit, CPU time and stuff. So what we need is just a count. So I could actually filter it, COUNT. Okay, container, page faults, restart count. That's basically for, if you look over here in the Kubernetes containers, long base, log bytes, log entities, entries. Look at global log based entries, log bytes, virtual machine, firewall, metrics, instance. See all this stuff. Consumed API, global. So firewall, guest, popular metrics. Like the metric, drop down and search for Kubernetes namespace, like resource usage or count. Apply filters to specify namespace if needed. Customize the visualizer style and save it. Select chart for pods again. Select tracking pod trends. In the metric dropdown, search for Kubernetes pod metrics like pod count or CPU usage memory. Customize the chart and save. 1 minute. So let's look at this. If we could filter this CPU memory, nothing like that. Nothing. Select a metric. Add filter. Global. Virtual machine instance. Audited compute. I don't know, for some reason it just keeps going down. Kubernetes cluster, 2 metrics. Namespace we're looking for, I don't know. Pod, that's one thing what we're looking for. Pod, so cluster, container. Look at the pod. Let's select the pod. It's for some reason it's just keep going back up. Man, this is not good. Is there an error with this? System, what is wrong with it? Let me just refresh this page. Go to the annotations. Cancel. Alert opened. You don't have to open up any kind of annotation. Okay. So alerts, annotation, select from a list of the system event types to annotate on your charts. This just lets you correlate specific events and observe performance trends. Add a widget. Again, we're going to try to add a chart. And we're going to select a metric. And we're going to go all the way to Kubernetes pod. And we're going to say pod volume usage. Okay? Look at that. I think that's more simple because if we look at like pod count or CPU memory usage, volume usage. So this one's like type unit 1 k it's metric. This fraction of the volume that is currently being used by the instance, this value cannot be greater than 1 as usage cannot be exceeded the value. Okay. Number of byte disk used by the pod. Number of byte disk available to the pod. Okay, I think we could do what is pod flow. Okay, so let's do volume capacity, number of byte disk available to the pod. Apply this. See, total is that. We're gonna have a pie chart or a donut chart. Pie chart, donut chart. And apply. Okay, so we got the Kubernetes pod. Volume capacity. Okay. After that, we could create another widget and we say pie chart, add a metric. This time we go for the namespaces. So we can't find it here, but we could say Kubernetes container. So I see cluster, log based log bytes, instance group. So number of virtual machines you could see. There's one virtual machine. You could apply this and you could see that one. Again, you could create more pods. Just add a widget. Then we say, pie chart, add a metric, Kubernetes container. They're popular. CPU limit utilization, CPU request utilizes CPU usage time, limit memory limit utilization, and memory usage. So again, consumed API, compute location, GCP location, global. What is in global? Popular metrics, and all that. Global Google service, VM, Google service. We have bytes count. Instance group. What is this? Instance group size. I don't know what instance group size is. We have Kubernetes cluster and we have log-based Kubernetes cluster limits, container. Okay, you could check out the restart count. Kubernetes node. Total cores, total memory, node flow, Kubernetes pod, logging, operation type. reduced API reserved unspecified, some virtual machine, VPC network, popular, CPU utilization, receive bytes, send bytes. So over here we have Kubernetes pod, bytes transmitted, bytes received. Trying to look for namespaces. We couldn't find anything related to namespaces. That's why I think the cluster matters. If you have a cluster, and it's more of like log based. So Kubernetes cluster limits, quota. Okay. Number of pods in a GK standard cluster, quota limit. So you can see over here how many pods we could create. We could create a number of 200,000 pods. You could just apply this and you can see over here. So these are the dashboards that we've created. I'm not adding more, but these were the ones that were available. After that, customize the chart type and save budget alerts and tracking costs. Go to budgets and alerts. In the GCP console, navigate to billing and budget. So go to budget. So billing. If you go here, and then we have budgets and alerts. So I'm just going to click this. So we say cost $4.90. Set a monthly budget for your create a budget alert. There you go. Set a monthly budget for your billing account. You'll get email notification as your costs approach and exceed the budget amount. This is good because it will tell you like if something. So billing budget alerts. When the free trial ends, all resources you created during the free trial are stopped and you will not be charged unless you upgrade to a paid cloud billing account. Note, the free trial period cannot be paused or extended. The free trial ends after all available credits are consumed or at the end of the free trial period, whichever happens first. So you can activate it, but we're not going to click on that. Billing health checks, and we have a budget alert. Set a monthly budget for your billing account. You'll get email notifications at your cost approach to see the billing. So yeah, so this is something. Over here, billing account overview. Yeah, my account name, payment overview. So what we're gonna be doing is there's like a custom number we could set, or even 1,000. So normally we have 300 free credit. I say maybe even $50 if it like compensates. You could add it. Create a budget alert. Set a monthly alert to monitor usage. 20 to avoid overspending. GCP will notify you if you exceed the set budget, allowing you to adjust resources accordingly. Let's add it $20. Okay, and then we have create. Monthly budget. Alerts have been created. View details on budgets and alerts. Important, setting a budget does not cap resources or API consumption. Because costs can take a few hours to be recorded, we recommend taking actions before your costs reach 100% of your budget. Okay? So we created that alert that would help us navigate. It's going to base on that email. Okay, now let's look at optional cost optimization. Limit active hours. Stop the cluster when not in use to avoid incurring hourly charges. Monitor usage regularly. Google Cloud Monitoring free tier features to track usage within the dashboard without additional cost. Use the free tier for testing. Google provides a free 50 virtual CPU hours per month for E2 micro instances in regions like US Central 1. And then the free 50 virtual CPU hours per month is basically for the E2 micro instance. This setup will enable you to track, namespace and pod trends in a cost-effective way within Google Cloud free trial limits. And basically, what you want to do is afterwards you want to save up cost, right? And it's a good idea to delete the cluster once you're done and to avoid any unexpected charges after your free trial ends. So GCP doesn't automatically delete or stop billing for resources like GK clusters, even if your trial period ends. So keeping resources active could lead to charges on your card. So what you want to do is go to the GCP console, go to the Kubernetes engine. So I'm going to go to the clusters. Let's put this back. One second. Let's go to the Kubernetes engine. Let's go to the navigation menu. And we go to the compute engine. I guess it's not the compute engine, but it's actually the Kubernetes engine. So Kubernetes engine, and we have clusters. We click on that, cross this out. Over here we have minimal cluster. Find your cluster in the list and select it. Click delete at the top. Confirm the deletion and wait for it to complete. Deleting the cluster will remove all nodes, workloads, and other associated resources. Deleting your cluster will also delete any resources within it like pods, namespaces, and associated persistent storage, which helps keep your project clean and free from extra costs. If you're doing ongoing experiments, another option to keep costs down is to use smaller preemptible nodes or a single node setup. Okay. But deletion remains the best choice to avoid any charges when you're not actively using GKE. So yeah, I'm gonna go into this detail view over here. Total virtual CPU is 2, but I'm gonna go and click on minimal cluster. After that, you can see over here that there's a detailed view, and you could have an option over here to delete your cluster. So when I click on this, this option cannot be undone. Deleting a cluster permanently removes all data from every pod within the cluster, as well uh, as as well as any containers running in each pod. Do you want to delete minimal cluster? Confirm deletion by typing the cluster name below. So we just have to type in minimal hyphen cluster, and when we click on delete, it's submitting the request. And it's not going to do it immediately, but it's going to give a status here is that it's being deleted, and after that it's going to be permanently deleted. So over here you can see on my deleting Kubernetes engine cluster, minimal cluster, it's almost being deleted. Hi Vikram. Okay, so I guess we're gonna be ending the stream here. Just making sure that this should be deleted permanently. And preemptive is the keyword that was chosen. If you look at it, preemptible nodes. What is preemptible? It means something can be taken over, supplanted, or appropriated. For example, you might say that advertising spots are more preemptible because they cost half as much to replace, to occupy land, to acquire, able to be supplanted, taken over, or appropriated. Cost half as much because they are more preemptible, among other reasons. A preemptible resource can be involuntarily and temporarily removed from a task without affecting the task execution state or result. And that's why it's saying if you're doing ongoing experiments, another option is to keep costs down is to use smaller preemptible nodes, which don't affect the overall project, or single node setup, but deletion remains the best choice. Yeah, and that basically deletes everything, and you clean up all your resources. Deleting the cluster will remove all nodes, workloads, and other associated resources. And we wanted to know what workloads are. Um, so we could say in a cluster. So If we get to the last, in Kubernetes cluster, workloads refer to the applications and services running on the cluster. They are the work that Kubernetes manages and orchestrates across the cluster's nodes. Now, Kubernetes workloads represents different deployment patterns and configurations that specify how your application components run. Here's a breakdown of some of the core workload types in. So you have pod. Pod is a deployment, a high-level abstraction that manages pods. Replica set, stateful set, daemon set, job runs a pod or pods to completion. Cron job, horizontal pod, autoscaler, HPA, custom resources. Each of these workload types have its own use cases and is suitable for different types of applications, allowing you to create a scalable, fault-tolerant, and resilient environment within a Kubernetes cluster. Thank you so much for watching this stream.